Hey, this is Mr. Soy, and I wanted to give you an example of a problem that you're going to be working on the worksheet assigned in Lesson 715 and 716, where we're looking at multiple representations of an exponential equation. In this case, the example, we're given a table of data, as you can see, and we're asked to find the equation, a graph, and a situation for this exponential data. In all circumstances, your first step is always to find your equation, because without those two pieces of information, you really can't find the other different pieces of representations for that. Now, in this case, since we're given a table of data, I'm basically going to be looking for finding my start value and my common ratio. Start value is the a in our standard form exponential equation, y equals a to the ab to the x. And then b is our common ratio. And the common ratio we can find just like we did when we were looking at the bouncing balls at the very beginning of this chapter, where we take the next bounce rebound height and we divide it by the previous one. The start value we also know is the y-intercept. So I'm always looking for that, either given in a situation where it crosses the y-axis on a graph, or in this case in a table where x is 0. Well, I can already see x is 0, and at that point y is 1,000. So I already know what my a is for this problem. It's 1,000. Now I need to find b, my common ratio. Well, the common ratio, like I said, is found by taking the next value in your table and dividing it by the previous one. So I'm going to take 1,060 and I'm going to divide that by 1,000. And when I do that, I end up with 1.06. Then I can come down here and I can take 1,123.6, divide that by 1,060, and I will get the same thing, 1.06. And we can continue that process, and each time we will find the same value, thus the common value, or in this case, common ratio. And so our b then is 1.06. All right, once I have both those values, I can create my equation. Y equals 1,000, and then in parentheses I put my common ratio, 1.06, and I raise that to the x power. This is my exponential model for the data that was in the table. So now we have our equation. The next step would be to graph it. Well, we've already graphed plenty of these using our TI-84 calculators and also using Desmos. And it doesn't really matter to me while you're working on the worksheet which of those two methods you do. If you do it on the TI-84, you're going to hit y equal, that's the button, and then you're going to put your equation in y1 and then set up your window so that you can see the actual graph. And then you would sketch that onto your worksheet. However, if you're using Desmos, where you put in the equation y equals 1,000 times 1.06 to the x, you will get a graph. You'll have to set up the window as well, but then you can actually export that out into your photo stream or screenshot it, either way, and then you can put that into your worksheet. My main goal with the graphing is to get you using the calculator. However, if you are better off using Desmos, or you don't have a calculator to use and you have to use Desmos, please feel free to do that and then copy and paste or screenshot and put it into your worksheet. So I'm going to check that off, that we've already done that, since we've done so much of that in class. So really the last piece that we need to look at is a situation that matches our model. Well, before I can come up with a situation, I need to find the growth rate. Because when I look at this common ratio, I can see that it's greater than 1. And any number greater than 1 that I'm multiplying by over and over again gives me growth. And in fact, in our table, we can see the values start at 1,000 and they keep steadily going up. Therefore, I already know it's growth. Let's go to the next page and let's try to find that growth rate, and then from that and our starting value, we should be able to come up with a situation that matches. All right, so I'm going to write my equation back up the top here. Y equals 1,000 times 1.06 to the x power. I can see that it's growth already, and we looked at that. But what I don't know is what my growth rate is. So I want to try to find that growth rate, because in all situations, we're always attempting to find some sort of percentage increase or decrease if it's decay for some initial value or our starting value. In this case, it's going to be a growth rate, and I need to find that. The way I do it is I look at my common ratio, 1.06. I can see that anything, I can see it's greater than 1, and anything over the 1 is the growth rate. Because 1 is 100% of something. And 100% of something is just everything I have to start with. What I want to find is how much more is going to be added on. So anything over 1 then becomes that growth rate. So I simply take my common ratio, 1.06, I subtract 1 from it, and we're going to call the growth rate R. And then all I have to do is that subtraction, and I end up with 0.06. This becomes my growth rate. Well, as a decimal, it's 0.06, but if I multiply that by 100, I end up with 6%. That's the growth rate for this particular model. Now I can actually look at trying to find a situation that would match it. I might look for something like population that's increasing, an investment that's increasing, or any sort of growth problem that would match, in this case, the data that we were given. Since I have my model, I'm going to come up with the following. I'm going to use an investment one. You invest $1,000 in an account that earns 6% APY, annual percentage yield. That means it's compounded every year. That's why we have a common ratio of 1.06. Now, I usually want to ask a question using the model that we would come up with for the situation. For example, how much would you have after 10 years? And that's the situation that matches the data in the table where we generated our equation, and therefore we are done. Thank you.